How many marks you aim for your IGCSE Paper 6? What if I tell you to aim for full marks or 40 marks? So you will look at me and say, is it even possible? Let me tell you this. It is very, very seriously possible. So in this video, I'm going to show you what you're supposed to do in order for you to score full marks or maximum marks in your IGCSE Paper 6. But not only that, I will also point out some common mistakes, some careless mistakes made by the students, which you are supposed to avoid. And on top of that, added to that, I am also going to give you some tips on in answering your IGCSE Paper 6. So stay tuned. Paper 6 that I'm going to discuss in this video is February-March 2024, Paper 62. Now what I promise, I'm going to show you how to score full marks, the common mistakes made by most of the students, and how to avoid making careless mistakes yourself. So let us begin with answering the question number 1 right away. So the first question, a student determines the mass of a meter roll by a balancing method. He is using the apparatus shown in Fig 1.1. A, the student places a circular load on a meter ruler shown in Fig 1.2. Determine the distance D of the center of the load from zero end of the ruler as shown in Fig 1.2. And Fig 1.2 is not to the scale. So I want you to underline because highlighter is not allowed in the examination hall. So whenever you have a pencil or pen, all you need to do is just to underline, oh, I'm supposed to measure distance D. And the distance D must be measured from zero end of the ruler or zero mark of the ruler all the way to the center of the load. Now, I don't have a problem with the zero mark because it has to start with zero, but I'm definitely have a problem with the center of the load. Could you see that this is a load and the center of the load, the value, the distance of the center of the load is not being given. So how do you find the distance of the circular load or the diameter of the circular load? So look, all you need to do is just to take these two end readings. First one and the second one is here. So the first one here, at the two curvature of the circular load, this is 26.5 cm and this is 29.5 cm. To find the diameter of the circular load, all you need to do is just to take 25.9 cm minus 26.5 cm. So the diameter of the load is 3 cm. And remember, look back at the question. The question asks you to take from the center of the load. So the center of the load is actually the radius of the circular load, which is 1.5 cm. How do I get 1.5 cm again? It is actually 3 cm divided by 2. So from zero reading all the way up to the center, from zero all the way to the center of the circular load. So how do you get the value of D? All you need to do is just to take 26.5. 26.5 cm plus 1.5 cm. So you got 28 cm. Now, before I fill in the blank for my final answer, in order for you to fill in the most accurate answer, first of all, we are using an apparatus to do our measurement. The apparatus is our meter ruler. So you have to check for the sensitivity of the meter ruler. What is sensitivity of the meter ruler? Sensitivity of the meter ruler is actually the smallest division of the meter rule. It is just the same as the smallest division of your cm rule. So the smallest division is the smallest scale on your cm rule or your meter ruler. It is 0.1 cm. Bear this in mind. Before you fill in the blank, you need to understand that your reading must follow the decimal point of your sensitivity of the apparatus. Since we are using a meter rule and the meter ruler has 1 decimal point because the sensitivity is 0.1 cm, so I'm going to fill in my answer as 28.0 cm. You have to follow the decimal point of the sensitivity of the apparatus. So 28.0 is the answer. B, the student adjusts the position of the meter ruler on the pivot until the meter ruler is just as near as possible to being balanced. Describe a technique for ensuring that the ruler is as near as possible to being balanced. It is very hard to find the balance point of your meter rule. Seriously, I did the experiment myself, and it's definitely require a lot of patience to do that. And even I cannot balance my finger on my CM rule. So what is the best technique to be used in order for us to make sure that the ruler is as close as possible to being balanced? First, you just place the pivot. Place, because you know that to find a balance point, you have to place the pivot at the center. But that is not always the case. Sometimes the ruler, the ends of the ruler are actually worn out, so it decreases the overall mass of the meter ruler. So you could not find the balance point very easily. But to save a lot of our time, I will place pivot at 50 cm mark on ruler. I'll just put it as ruler. And then after that, shift pivot slowly to the right of 50 cm mark. That means you shift maybe to 50.2, 50.4. Yeah, very, very slowly. Yeah, until the ruler tip. And then shift back the pivot until shift back the pivot towards right, towards left, yeah, towards left of 50 cm mark until ruler is horizontal. Horizontal means balance. It is like this. Now, the second part. The student finds that the ruler is as near as possible to being balanced when the pivot is at 47.6 cm. And you see, it is not 50 cm. Calculate the distance A of the center of the load from the 50 cm mark as shown in Fig 1.1 and use your value of D from A, part A, and the equation A equals 50 cm minus D. So very easy, you just follow 50 cm. A equals 50 cm minus D is our 28 cm, the one that we determined just now. So you will get 22 cm as your answer. So 22 cm is the answer. And calculate the distance B of the center of the load from the pivot as shown in Fig 1.1. Use your value of D from A and the equation B is equal to position of the pivot minus D. So position of the pivot is 47.6 cm. It is given. 47.6 cm minus 28 cm. And the answer is 19.6 cm. C, the student moves the load so that its center is above the 5 cm mark and balances the meter ruler. He repeats this procedure for the load at the 10 cm mark, 50 cm mark, 15 cm mark, 20 cm mark, and 25 cm mark. His results are shown in table 1.1. This is our table. And the question asks you to plot a graph of A, cm/cm, that's the unit of A. On y-axis, this is very, very important. So you have to follow the instruction very, very closely. Please make sure that A must be placed on the y-axis and B must be placed on the x-axis. Use the values in table 1.1. You do not need to start your axis at the origin. So most of the students wanted to start the axis at origin. You know what will happen when you start your axis at origin? Because all the values of A and B are way larger than 0. So your scale would be very, very small, and the scattering of your points will be very close to each other, which makes your calculation will be very, very inaccurate. So try to avoid this. In physics, it doesn't mean that you have to start your graph from origin all the time. You could start from any other value. So I'm going to discuss closely on this. So this is a table and this is a graph. I'm going to plot the graph and I'll show you how to plot the graph. First of all, like what I say, underline which is a y-axis, underline which is your x-axis. So I better label this. If you have pencil in the examination hall, you are supposed to use the pencil to label this as your y-axis. This is my y-axis and this is my x-axis here. And first of all, I would like to determine the scale on my y-axis. So I look at the smallest point and then the largest number, which I have to spread out on my y-axis. I better label my y-axis. Okay, start from here, 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 and here. So since the smallest value is 25, I would like to start with maybe 20. And then I put a 5 cm gap to each of my reading here. 20, maybe I put 5 cm gap is not enough the space. So I would put maybe 10 cm gap. So 30 cm, 40 cm, and 45 cm. So I can label my y-axis here, which is A/cm. Make sure that you label your y-axis. Most of the time, students forgot to label their y-axis, which causes them to lose mark. It is not worth. Right? What about the x-axis? Look at the x-axis is B/cm. So since the x-axis, the smallest value is 22 cm and the largest value is 40.5 cm, I would like to start my scale with 20 cm. And I put, since it is just until 40.5 cm, I put 5 cm gap to my scale. So 20 is here, 25, 30, 35, 40, and 45. So I can label my scale here. This is B/cm, done. And after that, I'm supposed to plot my point. Make sure that whenever you want to plot, your size of the X here must be as large as this one little box there. Remember that cannot be too large and cannot be too small because it will cause a very, very large error to your calculation of the gradient later. So I look at y-axis first, it is 45 and my x-axis is supposed to be 40.5. This is 45, 40. This is 40.5 is here. And my y-axis, which is 40, and my x-axis is supposed to be 35.2, which is somewhere here. My y-axis is 35. 1, 2, 3, 4, 5. 35 is here. And then my x value would be 31.5. Where is my 31? Is here. 31.5 is here. And my y value is 30. My x value will be 26. 25, 26 is here. My y value is 25, 21, 22, 23, 24, 25. 25 is here. And the x value would be 22.5. This is 21, 22, and 22.5. And after that, just use your ruler to draw a very nice best fit line. So I'm going to draw it right now. Okay, my best fit line. Your best fit line is supposed to pass through all the points, but if you cannot pass through all the points, all you need to do is to make sure that all the points are as close as possible to your best fit line. So I make sure that they are very, very close. It doesn't mean that the best fit line must pass through all the points, as long as the points are very, very close. Still determining this. Okay, this one is too far. Maybe like this. Okay, so you just use your ruler. Please make sure that you extrapolate the line. Make sure that you extrapolate. Don't just stop at the last point and don't just start at the first point. Okay, this is my best fit line here. I'm going to erase this one. Yeah, it is like that. So back to the question. The question asks us to determine the gradient of the graph. Show, this is very, very important, show clearly on the graph. So you have to show how you gain your gradient. You know that gradient, the equation of the gradient, the formula of your gradient is equal to y2 minus y1 divided by x2 minus x1 of your straight line graph. So my point would be somewhere here. Maybe I take a one that is, um, okay, maybe this point. And then the other one, okay, I determine the coordinate of this point first. This is 44 x-axis. And my y-axis would be here. Okay, look at my y-axis. Okay, 45, 46, 47, and 48. So my y-axis is 48. And then my y-axis is 48. Okay, this is 45, so this is 48. And the other point would be maybe I need to make sure that it occupies half. Okay, this triangle must be as large as possible. So this is 20, 21, 22, 23, 24. This is 24.5, my x-axis, and my y-axis 25, 26, 27. So I have my x2, y2, and x1, y1. So y2 is 48 minus 27, divide x2 is 44 minus 24.5. 48 minus 27, divide 44 minus 24.5. And the value that I got was 1.08. So I just label here, I just fill in the blank here, 1.08 as my answer. So there's no unit for gradient. It is just math. D, calculate the mass m of the meter ruler using the equation m is equal to k over g minus 1, where k is 25 gram. Give an appropriate unit. If you don't feel like changing the gram unit to kilogram, it doesn't matter because the question did not ask you to change the unit. M, okay, I just use m is equal to 25. Because the k value is 25, I just sub it in. And the gradient is 1.08 minus 1. So I get a value here, 25. So my value of, I will redo 1.08. So my value was 313 gram. So 313 gram is my value. So the mark scheme, given that the range of the M that you are supposed to obtain is between 100 gram to 400 gram. Make sure that the value that you obtain must be within the range in order for you to get that 1 mark. E, the accuracy of the result obtained by this procedure depends on the meter ruler without a load, balancing with the pivot at the 50 cm mark. And a student finds that if this does not happen, so she adds a small piece of modeling clay to one end of the meter ruler to correct it, just to make sure that the ruler, force the ruler to be balanced at 50 cm mark. Suggest if this is suitable change for this experiment. Whatever that you add to the meter ruler, that is not the original mass of the meter ruler. That is no longer the original meter ruler. So, yeah, is this suitable? You ask yourself. Of course, this is not suitable. The answer is no. Why? Because the overall or the total, okay, I use the keyword, the total mass of meter ruler increases. So that is not the original meter rule anymore. So that is not correct. Now, the second question. A student investigates a circuit containing different combinations of three resistors. She first uses circuit A, shown in Fig 2.1. So all the three resistors are arranged in series. Ammeter is used to measure the current. Remember that. And A, on Fig 2.1, draw a voltmeter connected to measure the potential difference for terminals P and Q. They already give you the hint. So terminal P, terminal Q. Do you still remember the symbol of voltmeter? It is just a circle with a capital V inside. That's all. B, the student measures the potential difference V for terminals P and Q and measures the current I in the circuit. The meters are shown in Fig 2.2 and Fig 2.3. Read and record in the first line of Table 2.1 the values of V and I shown on the meters in Fig 2.2 and Fig 2.3. So circuit A, V reading is 3. The gap is 0.1. So this is 3.1 over here. So I'm just going to record it as 3.1. And the I reading is here. So this is 0.02. 0.1 is here. So this is 0.12. So this is 0.12. I'm done with that. And C, circuit B, the student connects the resistors between the terminals P and Q as shown in Fig 2.4. She measures and records in Table 2.1 the values of V and I for this circuit. And circuit C, the student connects the resistors between terminals P and Q as shown in Fig 2.5. She measures and records in Table 2.1 the values of V and I for this circuit. Calculate and record in Table 2.1 a resistance R for each unit. Use the values of V and I from Table 2.1 and equation R is equal to V over I, Ohm's law. Add units to the column headings. Column headings is actually the title of the table. So I'm going to add the unit here. First, the unit here supposed to be volt. Okay, V measured in volt, I measure in ampere, and R measures in ohm. So for circuit A, how do we find R? R is equal to V over I, so it is equal to 3.1 divided 0.12. So the answer is equal to 25.8. Circuit B, R is equal to V over I. It is 2.9 divided 0.22. So the answer is 13.2. And circuit C, R equals V over I, which is 2.6 divided 0.86. And the answer is 3.02. Now D, part 1. Calculate a resistance RA. Use the value of R from circuit A and the equation. RA is equal to R over 3. RA, the R value from circuit A is 25.8. So I'm going to use 25.8 divided by 3. 25.8 divided by 3. And I got 8.6 as the answer. 8.6 ohm as the answer. Calculate a resistance RB. Use the value of R from circuit B and the equation R over 1.5. So RB is 13.2. Take 13.2 divide 1.5 and I got 8.8 ohm. Calculate a resistance RC. Use the value of R from circuit C. RC is equal to 3.02. So I take 3 times 3.02 and my answer is 9.1 ohm. So the student suggests that RA, RB, and RC should all be equal. State whether your results support this suggestion. Justify your statement with reference to values from your result. Now, for this kind of answer, there is no wrong and there's no correct answer. It all depends on how you justify your answer. So my statement is no. Why? Because justification means that you have to state with a reason. If you say no, why do you say no? Give me a proof. The proof from where? From the calculation. So my justification is because the difference, the differences of RA, RB, and RC vary between 0.2 ohm to 0.5 ohm. It's a big difference. From 8.8 and 8.6 is 0.2 ohm. So it is a very large difference. So which is exceeding. Always write this, exceeding the limit of experimental accuracy. So if your statement is yes, so you show that you get a small differences between all the values of RA, RB, and RC. And how you answer after that, you justify which is within the limit of experimental accuracy. Always use limit of experimental accuracy. E, a student investigate the resistors in circuit A using a variable resistor to change the current in the circuit. In the space below, draw the symbol for variable resistor. Do you remember? The variable resistor is a rectangular shape here with an arrow to show that it can be varied. So this is a symbol of variable resistor. And the second part suggests one advantage of using a variable resistor to change the current in the circuit. Resistance. Why we use variable resistor instead of using a fixed resistor? Because resistances can be varied easily. You want to change it to large resistance, you just use the slider to slide it over. And you want to change it to a smaller resistance, you just slide it over. You don't have to keep on changing the resistor. Now, question number 3, a student determines the focal length of a converging lens by 2 methods. A, the student set out the apparatus as shown in figure 3.1, suggests one precaution that must be taken. This is very, very important. Must be taken when setting up the apparatus to ensure accurate measurement, not just to ensure the accurate measurement, and also ensure that there will be image formed on the wide screen. This is a must, right? So you have to make sure that the lamp, the lens, and screen must be aligned on a straight line. They must be in straight line. This one cannot move out from the line, or else the image cannot be formed on the screen. B, the student sets the distance U between the illuminated object and the lens to 20 cm. He places the screen near the lens and moves the screen until the sharp image of the illuminated object is seen on the screen. First part, describe a technique for obtaining an image that is as sharp as possible. You know, due to some other light sources, we might not be able to determine the image, the very, very sharp image, the sharpest image. So it is based on our own judgment. So all you need to do is that you need to move the screen forward and backward a little bit. So when you think that, okay, try to move forward just bit by bit until you see that, oh, this is the clearest one. But when you shift it up a bit, you could see that the clearest image suddenly disappeared to become a blur image. And then try to shift it back. That's the clearest image, or the sharpest image it is called, right? So I would say that move screen back and forth slowly. And then it is our own judgment after that to determine the sharpest image. Measure V1, the distance from the lens to the screen on fig 3.1. So you have to use your cm rule. V1 is here. So place your cm rule on top of your paper. So the V1 that you are supposed to get is about 8 cm. Fig 3.1 is drawn to 1/10 scale. Calculate V1, the actual distance from the lens to the screen. So all you need to do is just to times 10 because this is 1/10 of the scale. So just take 8 times 10, you get 80 cm. That's the answer. And C, the shapes of the illuminated object and the image seen on screen are shown full size in Fig 3.2 and 3.3. Measure H0, the height of the illuminated object as shown in Fig 3.2. So take out your cm rule and measure H0, and the value that I got was 1.2 cm. Measure H1, the height of the image on the screen as shown in Fig 3.3. So the value that I got was 4.8 cm. And the second part, calculate the value of m for the magnification using the equation m is equal to hi over h0. So just use 4.8 divide 1.2. 4.8 divide 1.2, you should end up getting 4. Magnification is 4. D. Calculate a value f1 for the focal length of the lens. Use your values from B2 and C2 and equation f1 is equal to V1 over capital M plus 1. So my f1 would be my V1. Where is my V1 value? Let me see. My big V1 value. So it is 80 divided by big N, 4 plus 1. So 80 divide 5, and I got 16 cm. So 16 cm. Remember the unit of focal length. That is the unit. Length is measured in cm. I don't have the unit for magnification because H1 is measured in cm and H0 is measured in cm. You just cancel off the unit. There is no unit for magnification. E, describe one difficulty that is experienced when using a ruler to measure the height of the image in this experiment, suggest an improvement of the apparatus to overcome this. One difficulty is when you measure and you use a ruler to measure the height of the image on the screen, that ruler that you are using is a wooden meter rule. It is an opaque material that will be blocking the image on the screen. So I will say that, okay, my meter ruler blocks the image on screen. So it is very hard to measure the height of the image. Improvement is that you might want to use a transparent. Use a transparent meter ruler for measurement. That's all. And F, the student adjusts the position of the lens so that U is equal to 40 cm and obtains a new value V2 for the distance between the lens and the screen, which is 25.1 cm. Calculate the second value F2 for the focal length of the lens using the equation F2 is equal to U V2 E over U plus V2. So I have to look at the value of U first. My value of U, where is my U? This is B. F. Oh, U is 40. 40 times my V2 is 25.1 divided by U is 40 plus 25.1. And I got 15.4 cm. Remember the unit, cm must be put in. And G suggests which value of the focal length F1 or F2 might be more accurate. Explain your answer. What do you think? Which value is more accurate? I would say that the value of F1 would be more accurate. F1. Let me see if it's adjust the position of the lens so that U is equal to 40 cm, obtain the new value. F F1 is calculate the value F1 of the focal length of the lens. Use your value. So we just use the magnification. Oh, so you look at F1. The measurement of F1 is with difficulty because my meter rule is blocking the image, remember? So it makes my measurement of H0 and H1 will be not accurate. So it affects the value of magnification. And when I sub into the equation of F1, since the value of magnification is with error, is inaccurate, so the value of F1 will be less accurate as compared to F2. So I would choose F2 would be more accurate. F2 is more accurate because, okay, explain your answer. You could say that the percentage error of F2 is lesser as compared to F1 because the value of magnification is very inaccurate in F1. So that is why I choose F2. And question number 4, my favorite part. And this is the part that most students think that it is very hard to score high marks. So my suggestion is that the tips is that you just follow whatever being asked here. Very easy. There is no accurate format. There is no fixed format here. All you need to do is just to follow whatever the question asks. I'll read the question first. A student investigates the effect of insulation of the cooling of a liquid. Plan an experiment which will enable her to investigate how changing thickness of insulation surrounding the beaker affects the rate of cooling of hot water in the beaker. Apparatus available includes a glass beaker, supply of hot water, a lid to feed the beaker. Oh, the lid is given, and strips of insulation which can be cut to size. In your plan, list any additional apparatus needed, explain briefly how to do the experiment, including the measurements to take so that the rate of cooling can be determined, state the key variables to keep constant, draw table, tables with column headings. They stated very clearly. So you have to input the title for the table to show how to display the readings. You are not required to enter any readings in the table and explain how to use the readings to reach a conclusion. You may draw a diagram if it helps to explain your plan. I would strongly suggest you to draw a diagram because whenever when you answer your paper 6, right, you are given only 1 hour to do so. So sometimes you might use a lot of time in answering other part of the question. You might have not enough time to answer your paper 6. So diagram will help you to give mark. The examiner will try their best to give you the mark. So try to draw a diagram. So not only diagram, but a labeled diagram is needed. So how do I draw a diagram? This is my diagram. I have a beaker here since they give me a beaker. And then these are all insulating material. Okay, but not just diagram. You have to label your diagram. And this is a water. And this is my thermometer, rate of cooling. Remember, you want to measure the temperature drop. So thermometer is a must. Without the thermometer, how do you measure the rate of cooling, right? So I have measuring cylinder. If you don't want to draw measuring cylinder, it doesn't matter. So I have measuring cylinder that I pour the water into the beaker. So I have to measure the volume of the water first. So this is my measuring. So I label right now, measuring cylinder. Very important apparatus, thermometer. This is water. This is my beaker. And then this is my insulating strips. Okay, insulating strips. That's all. So when I draw a diagram, I could plan my experiment in more well-prepared way. Instead of just cancel here and shift arrow up here and there, examiner will get very headache when you read your answer. He or she reads your answer, right? So after that, in your plan, first of all, I should include additional apparatus. So I write here, make sure that my plan, whatever is asked, is included additional apparatus. So additional apparatus that I want to include here, rate of cooling, I need to use thermometer. And then I want to measure the volume of the water, so I use measuring cylinder. And rate, R-A-T-E, related to time, so I need a stopwatch. I'm done with the first part. So whenever I'm done with the first part, I put a tick here. And the second part, explain briefly how to do the experiment. That is the method of the experiment. So I put here, I use different colors so that it's easier for you to see. Methods. Be polite. Ask the examiner to look at your diagram. Set up apparatus as shown in diagram. After that, the second method, okay, so I say measure 200 cm cube of water by using, let the examiner know how you measure that amount of water using measuring cylinder. And after that, pour water. Oh yeah, okay. Before I pour the water, I need to heat out the water because I need to measure the rate of cooling. Remember? Heat water to maybe heat water to maybe 100 degrees Celsius if you like it. And then after that, pour water into beaker. And after that, okay, I forgot to draw a lid here. So I'm supposed to draw a lid here to cover it. Okay, this is my lid. So I better label this. Okay, this is lid because I want to avoid some of the heat to be lost to the surrounding. And then take initial temperature of water by using thermometer. And after that, cover the beaker with 1 cm thick in insulating strip. Insulating strips. And after that, take temperatures of water every 30 seconds until 180 seconds. And then repeat. Make sure that you repeat the experiment because in physics, repetition is very important. Repeat the experiment with maybe 2 cm, 3 cm, 3.5 cm is up to you. Okay, 4 cm and 5 cm thick insulating strips around the beaker. Lid, you are using the same lid. Right, I am done with the method, so I can put a tick here. State the key variables to keep constant or the one that you want to control. So key variables, this is plural, so variables to be kept constant. So I might want to say that same type of material of insulating strip because they didn't say what type of material is that. And then maybe same starting temperature and same volume of water. So I have measuring cylinder to measure the volume of the water and make sure that it is the same all the time. So I am done with this part as well. Done with this one. And then after that, I'm supposed to draw a table. So very easy. Okay, just draw a table here. Table. So I have here thickness of insulating strips. I have time here. Thickness. Okay, you have to slash and then you have to put the unit. And then I have a time here taken, right? I have to slash, put the unit as well. And then I have temperature slash unit, and then rate of cooling. Rate of cooling slash degrees Celsius per second. So thickness of the insulating material, if you want to fill it in, you can fill it in because I stated 1 cm, 2 cm, 3 cm, 2.5 cm. So you can state that. If you don't want, just leave it like that. So I'm done with the table, and then I have to explain how to use the readings to reach a conclusion. So I said that, okay, first of all, I would like to state here rate of cooling, how to calculate the rate of cooling. Rate of cooling can be calculated by change in, okay, by in temperature per time taken. So change in temperature, temperature at 0 degrees Celsius before you start. Temperature at 0 seconds, sorry. Temperature at 0 second before you start to measure the time. That is your initial temperature. And then minus the temperature or the difference between the temperature after every 30 seconds. That is called the change in temperature. Time is 30 seconds, 30 seconds, and at 30 seconds, 60 seconds, etc. And conclusion here. Okay, how you will reach your conclusion? I would say that compare the thickness of insulating strips with the rate of cooling. So that is all about February, March 2024, paper 62. So I hope you find benefits in this video. You can also join my Facebook group. The link is actually attached in details. So make sure that all you need to do is just to make sure that you answer 3 questions seriously. So the PDF answer for this paper will be uploaded to my Facebook group. Please, if you need this paper, make sure that you join my Facebook group. Link is attached below. So see you again in my next video. Bye.